Imagine a tiny particle drifting at the edge of the Milky Way, a single element that could solve the next big challenge. Imagine you had the power to reach across the stars and grab it. Our world is immersed in a galaxy of data. Data that connects us, cures us, enables us to do more. Data that helps us innovate wherever imagination takes us. In 1969, Apollo 11's guidance computer was limited to 72 kilobytes as it traveled to the moon. Now, we have exponentially more power in the palm of our hands. This precious resource demands a trusted partner to harness and make every bit of it intuitively accessible at the speed of our ideas. The speed of SQL Server and Azure SQL, the latest evolution of data management's highly secure, supercharged platform, enabling you to break performance barriers and boost agility. Azure SQL Database's hyperscale capabilities allow you to auto-scale dynamically. Advanced data security keeps hazards at bay with a single click, while built-in cloud intelligence eliminates worry. Machine learning services enhance the value of your data by importing adjacent code to create models faster than ever. And with cross-platform solutions like Azure Arc, SQL Server and Azure SQL products can be leveraged virtually everywhere. Our team is motivated to consistently improve this new breed of database without disrupting the application of our existing technology. As many of the world's critical systems and most influential corporations deploy it, and agencies on our most important front lines depend on it. Businesses like Balzano that leverage SQL Server big data clusters to help radiologists interpret medical images, or Zeiss that use Azure SQL Edge to constantly improve the manufacturing of optical lenses. And organizations that help us dream bigger, like the Sloan Digital Sky Survey that built its ever-expanding database of 200 million galaxies and 260 million stars on SQL Server. Imagine what your data could dream up. Imagine unparalleled access to that next great innovation. Together, we can reach it. At the speed of SQL Server in Azure SQL.
As you saw from this video, SQL is truly everything you need it in new and exciting ways. Hello, I'm Bob Ward from Microsoft. I'm here joining you from the Microsoft Technology Center in Irving, Texas. Welcome to the 2021 Data Platform Summit. Microsoft is proud again to be a supporter of this really great event. Our heartfelt thanks go to all the people that have worked so hard to make this event possible. I'm excited today to be joined during this session by my colleagues Buck Woody and Anna Hoffman. Together, it's our intention to explain all the places SQL exists, from the edge to the cloud. We'll help you decide what to use when and give you the latest exciting innovations for what we call the world's database. I think it's important to first look how SQL Server has become a data platform over the years. It all started with desktops. Look right here. This is a diskette I was given as an employee at Microsoft in 1993 to install SQL Server for OS/2 on 16 megabytes of memory of a computer. But over time and over the years, SQL Server evolved to become very popular for department servers, and then eventually even to the enterprise space, proving ourselves not just as ease of use, but great price performance as known through our TPC benchmarks. As we moved to the 2000s, we became all of a sudden one of the first vendors to put a database as a service, or SQL Server, in the cloud. And then in 2017, we kind of shocked the industry by running SQL Server now on Linux, SQL Server now running on the platform of your choice. And then finally, SQL Server is not just known as a database anymore, it's a data platform with things like machine learning services and Polybase. Now, you're looking across all these different assets for SQL. What has been proven over time, though, is an engine that is known as industry-leading and innovative in security, performance, and availability. With that context in mind, let's take a look at all of our assets SQL Edge to cloud. It all starts at the IoT Edge, with SQL Server running on even ARM IoT Edge devices. Or SQL Server 2019, our latest version of SQL Server, which includes innovative technologies like big data clusters or accelerated database recovery. And of course, we've mentioned SQL Server runs on the platform of your choice. So SQL Server running on Linux unlocks the ability to use SQL Server in containers or in Kubernetes. If you think about the public cloud, SQL exists as Azure SQL in SQL Server as Azure Virtual Machine as an infrastructure as a service, or as Azure SQL Managed Instance, a full SQL instance run as a platform as a service, or Azure SQL Database, unlocking new innovations like serverless and hyperscale. Now, you think about the SQL Server on-premises assets and the public cloud assets, we now have a suite of hybrid assets, whether that be SQL Server on Azure Arc enabled servers, allowing you to bring the power of Azure to existing SQL servers, or what we've just announced recently, Azure Arc enabled SQL Managed Instance, bringing you the Paas capabilities of Managed Instance into the infrastructure of your choice. You're looking at this now and wondering, Bob, I cannot keep up with all these technologies. How am I going to learn everything you're showing here? Well, keep this in mind. Number one, it's the same core engine, the same capabilities of security, performance, and availability that are stitched across all these SQL Edge to Cloud assets. As a developer or a programmer, the same T-SQL language exists across these, or the provider or language of your choice for applications that can be written once or deployed anywhere in the SQL Edge to Cloud environment. And then finally, tools you know and love, like Management Studio or command line tools, or even PowerShell, or the new Azure Data Studio tool. All are compatible to connect and work across all these assets. So it's our intention in the rest of this session to go deeper into each of the SQL Edge to Cloud assets and describe what to use when. When would some of these be appropriate for you? It could be even a combination of them. Let's first explore the first asset on the chart, which is Azure SQL Edge. So let's start our journey by first exploring an innovative technology we've recently announced over the last year called Azure SQL Edge. You know, over the last few years, customers like 3M approached us and said, IoT technologies are extremely important for them to continue to innovate and move forward their business. But the problem they faced is many IoT devices were not always connected to the internet or semi-connected, and these devices output a large amount of telemetry needed to process information to do things like machine failure prediction. So we decided to go innovate SQL Server in a way to run actually on edge devices to push down processing of information from devices to the actual IoT edge itself. In order to do that, we had to build a very small footprint of SQL Server and enhance it to be able to run not only on Intel devices, but on ARM devices, a very popular processor on the IoT edge. Now, not only did we need to go innovate SQL Engine in this way, but we need to build in things like time series and streaming, integration with technology like Kafka and streaming analytics right into the SQL Engine. We need to be able to still move data natively into Azure once processing was finished. And we still wanted the power of SQL Server to be part of the engine, so we instrumented SQL in a way where we reduced the footprint but left very core features like SQL Server security and things even like column store indexes to be part of that engine. And the promise of Azure SQL Edge is to go develop an application once and run it anywhere you need it, even the IoT edge. So consider this scenario. A company like 3M needs to do a better way of predicting machine failures of manufacturing equipment. See, right now it may be kind of a fixed schedule they go maintain their machines. So could we take the power of the SQL Server engine, which includes technologies like machine learning services, and run machine learning models directly on an IoT edge device, taking the streaming of telemetry data and doing prediction for the device itself, and then pushing those predictions up to the cloud, or even notifications to the manufacturer when they need to go maintain equipment. That is truly the story of Azure SQL Edge. It's taking, again, the power of SQL Server, running in a small footprint on the IoT edge, and pushing data processing or machine learning down on the device itself. If you think about SQL Server on premises as a technology, SQL Server 2019, we believe, is a modern data platform that solves a lot of challenges for customers and brings some amazing innovation. So if you look at the top here and kind of move left to right, you think of big data clusters, bringing the power of big data technologies with things like Hadoop and Spark and integrating that with the power of SQL Server. Or including technologies like Polybase, reducing the need for data movement. Imagine trying to query all the data on the icons you see there and joining them together and never move any data, using the power of the SQL Server query processor engine itself. And then you think about modern data platforms with compatibility, imagine taking a backup and any one of these icons you see in the middle here and restoring it to any one of them with full compatibility. And then to the right-hand side, in previous versions of SQL Server, we introduced machine learning services built into the database engine, co-located with the engine on the same server. With technologies like R and Python, we extended that model, including languages like Java. Now, if you look at the bottom half of this screen, this is the power of us innovating the SQL Server engine in the areas of performance, security, and availability. So on the bottom left-hand side, you think about intelligent query processing as a technology where you actually make no code changes, but get faster for your application. Look at a company like Bank Tao. They actually upgraded during our CTPs of SQL 19 to SQL 19 with the latest compat levels for databases, and their performance increased like 50%. And they called us and said, what did we do wrong? How did performance get that fast just by moving to the latest compat level? We didn't change any code. And we said, it was intelligent query processing, our built-in query processor adapting to new customer scenarios and making their code run faster. You think about security, we enhanced our always encrypted technology to support enclaves and supported new paradigms like data classification for scenarios to help you with things like GDPR compliance. And then on the bottom right-hand side, the amazing innovations of accelerated database recovery built into the SQL Server engine to avoid those common problems you've seen before of long-running transactions. Problems where blocking during rollback of a transaction would cause your business to go down. Or perhaps maybe if SQL restarted, a long-running recovery would have to happen. Or your log running out of control. All those problems are solved with accelerated database recovery. So if you look at all the assets I show in here, all the features and capabilities, and the big features of SQL 19, this is why I believe it's a data platform. It's innovation at the database engine, powering above amazing new technologies like big data clusters, like Polybase, running on containers or Linux, or even in machine learning services. Now, to see the power of SQL Server 2019 combined with technologies like machine learning services, which I believe makes SQL Server a data platform, I can think of no better person to show off how these worlds have come together than my colleague Buck Woody. Buck, show us what you have today on how SQL Server and machine learning services open up new possibilities for applications and for businesses.
Thanks, Bob. Machine learning is the process of applying algorithms to data to create a prediction or classification. Starting in SQL Server 2016, Microsoft realized that data scientists wanted a secure, high-performing location to create, train, and deploy their machine learning models. So we enabled the R language for the SQL Server platform. In the latest version of SQL Server, we've added not only the Python language to the platform, but the ability to add other languages such as Java. We've also added scale-out machine learning capabilities inside big data clusters with Spark, all while maintaining security for the data platform. You can see here that data scientists can use familiar tools such as Jupyter Notebooks for every phase of the team data science process, from exploring and visualizing data through creating features using powerful transact SQL statements, training and saving a Python model directly in the database, even with versioning, all the way out to scoring or creating predictions and classifications, either in batch or single mode, without ever leaving the security and performance of SQL Server. While these are exciting new developments for data science teams, the database developers and database administrators wondered if they could use the models that were created by the data scientists directly inside their Transact SQL. And this would allow them to do predictions from data they already have in a table, or create a simple stored procedure that returns the prediction or classifications inside their code. The predict T-SQL statement allows exactly that. The data scientist builds and deploys a machine learning model to SQL Server, and the developer can simply call it in T-SQL, even calling out to a specific version. Now, Microsoft actually has a large portfolio of pre-built artificial intelligence systems called cognitive services. They do everything from vision, language, speech, decision-making, and even intelligent search. Now, these are services you call using an API whenever you want to make a classification or to do a prediction. These services are created by world-class data scientists with best-of-breed algorithms, and they're available as a simple API call. And the predictions they make actually just get better with time. You can see an example of a text analysis here that's used to get a sentiment score. So what if you took SQL Server's machine learning services and made a stored procedure that allows the DBA or developer to call out to one of these pre-built AI algorithms and create predictions right within their code, all without a data scientist involved? Let's take a look at how that works. As you can see here, I've got some data stored in my database from customer feedback on our products. I've selected one here, and you can see there's a few sentences in the response. It's often difficult to write a prediction that includes not only the overall sentiment, but takes into account each individual sentiment. In this stored procedure, the DBA calls out to Azure Cognitive Services to the text sentiment analysis function of Azure Cognitive Services, the one you just saw. After getting the desired sentiment, the text is passed to Azure. Cognitive Services does the prediction and includes the response. Now, I've formatted the response here so we can read it a little easier. And as you can see, you get not only the overall sentiment, but the sentiment for each sentence. This means a developer or DBA can make use of lots of powerful artificial intelligence features, all without having to write any machine learning themselves.
Hey, thanks, Buck, for that demonstration. I love the way you showed us how SQL Server machine learning services can be combined together, and it seems complex, yet you don't have to really be even a data scientist to put and integrate those technologies together. We've talked about Azure SQL Edge. We've talked about SQL Server 2019. Now let's talk about SQL Server running in containers. You know, over the last couple of years, I've been talking about how SQL Server can run with container technology, and I've had this question. People have asked me, why would you do that? Why would SQL Server and containers be a great combination for me to run? Well, consider the following. Number one, it's very portable technology. You know, it's funny, I had a challenge one time. I was at a conference speaking about SQL Server containers, running my Windows laptop, and somebody from the audience raised their hand and said, look, I love the fact you're talking about Linux and containers and SQL, but I'm not feeling the love as a MacBook user. So, you know, Bob, you're just using Windows here. I'm a MacBook user. I don't understand how this could be better for me. How is it portable? Well, here's my challenge. I didn't know if this was going to work at the time, so I went ahead and did it anyways. I said, hey, I'll tell you what. Within 5 minutes, I bet on your MacBook, you can deploy SQL Server and a native tool, both running on Mac without any Windows software at all. Well, this particular person was a little bit skeptical. I said, hey, by the way, if I'm wrong about this, put it on Twitter and tell me I'm wrong. So the next day, this person approached me and said, hey, I put on Twitter your challenge and you were wrong. And I said, what do you mean I was wrong? I can't believe that didn't work. I mean, you just use like a Docker container runtime to pull down a SQL Server container image. That's not Windows. And you pulled on Azure Data Studio, runs natively on MacBooks. How did that not work for you? You said, oh, it worked. It just didn't work in 5 minutes. It worked in 3 minutes. It's all about portability. Anywhere a container runtime can run an image of SQL Server, you can run SQL Server in a very portable way. And containers are a very lightweight run of SQL Server. In fact, did you know on SQL Server on Linux, we don't support multiple instances like we do on Windows, but you don't need to. You would run multiple SQL containers in your virtual machine or bare metal machine to achieve that multi-instance concept. In fact, one of the myths about containers, I believe, is that it replaces virtual machines. It actually complements virtual machines. Many people, like in this diagram you see here, will run multiple container instances because, you know, in the end, a container is just an isolated process, a process run in isolation, directly connecting with the operating system. So that reduced footprint can help you maybe consolidate your SQL Server footprint. Containers provide consistency. Imagine now not needing a developer SQL Server anymore. In other words, your department may have a SQL Server shared across developers, but let's face it, developers sometimes are always messing it up with changing configurations or changing something that affect all users. What if you now could give a container image, a customized image, based on the SQL Server image, with the application, scripts, and tools, along with the specific cumulative update of SQL Server you want all your developers to develop against or test against? And even consider the fact that with Azure DevOps, there's automation now supplied in terms of running with containers. In fact, the link that you can get when you get this deck afterwards shows a video of me at Microsoft Build demonstrating how Azure DevOps can automate the process of building apps for SQL Server, all with the power of containers. And then finally, consider the amazing story of containers with efficiency to reduce downtime. So no longer with containers do you patch SQL Server. You simply switch containers, and here's what I mean by that. If you see in the diagram right here, you could have on a given virtual machine a container running a given cumulative update of, say, SQL 19, pointing to your databases on persistent storage, including your system databases. Now, if you want to move to the latest cumulative update, you simply stop that container, start up a new container of the next cumulative update you needed, because container images are pre-installed versions of SQL Server at the cumulative update level. You start up the new cumulative update, you are now upgraded to that latest version. Why? Because cumulative updates are compatible within major versions of SQL Server. Which means, by the way, if you needed to roll back that cumulative update, you could simply stop the new one, start the old one, pointing to the same set of databases, and within seconds you have now rolled back your cumulative update patch. That's a great story to help reduce downtime and make you more efficient when you're trying to update SQL Server. Companies like DV01 have been able to take the power of the SQL Server engine, including things like column store indexes, and make their application run a lot faster but a lot more efficient because containerization is an environment they need for their business. You know, I've shown you a lot. We've already shown you Azure SQL Edge. We've shown you SQL Server 2019, including a great demonstration by Buck of combining SQL with machine learning services. And now we've shown you the power of SQL Server with containers. You know, it's time to switch gears a little bit and move up based on the original diagram I showed you and talk about Azure SQL, the world's database, SQL Server running in Azure, the world's computer. Now, if you think about SQL running in Azure, the Azure public cloud, I've had customers come to myself and my colleague Ann Hoffman and say, what exactly is Azure SQL? Is that a product? Well, it turns out it's a portfolio of services of how SQL Server runs in the Azure public cloud. It all starts on the left-hand side with SQL Server running in Azure Virtual Machine. We call this infrastructure as a service because Microsoft will manage the infrastructure, the host, the networking, the storage, all the hardware behind it, where you control SQL Server running in a guest operating system. This is very much like you're running in your own environment with, say, SQL Server running in VMware. You have full control here. You run a complete SQL Server licensed product, whether it be running on Windows or Linux or the version of your choice, and you manage SQL and everything about it and the operating system in that guest OS. Now, along the way, we're going to give you some management features to help you if you register your SQL Server in Azure, including some licensing benefits. Now, in the middle here, we call this Azure SQL Managed Instance. And there's a very good reason why it's called Instance, because it is a full SQL Server instance. Think about using Management Studio and connecting to an Azure SQL Managed Instance. It's going to look like an Object Explorer, much like a full SQL instance. So you unlock the power of instance level features like replication or SQL Server Agent. But it's managed. It's known as a platform as a service because we're going to automate a lot for you. We're going to make deployment easier. We're going to put everything in the background for you. You don't even worry anymore about a virtual machine or operating system. You don't really even care. You just focus on that SQL Server instance. And then furthermore, we're going to give you more managed capabilities, things like automated backups or automated high availability built into the infrastructure just by you declaring you want a managed instance. And on the right-hand side, another platform as a service offering, which is the most fully managed service, is Azure SQL Database. It's great for new cloud-born applications, applications that want to build a new app in the cloud and connect to just a database. Because of the fact that you're just asking for a database, it allows us on the back end to give you new innovation not possible in the other two options, including things like serverless, where you have auto scaling or even paused compute during idle periods. You only pay for what you use, or even hyperscale, where you can go up to hundreds of terabytes of data in SQL Server and get read scale capabilities on the fly. So this is the family of Azure SQL. If you think about the easiest lift to shift option, the migration option, it's the left-hand side. If you just want to move SQL into the cloud very quickly, it would be SQL Server in VM. We have great migration stories with Azure moving into managed instance for SQL into managed instance. But it's more of a modernization play. You'd like to migrate SQL Server, but you want to be more modernized in those fully managed service capabilities. And then finally, on the right-hand side, Azure Database is really made perfect for those new applications. You look at a company like Allscripts, they needed all three of these options. They wanted to quickly lift and shift some virtual machines into the cloud for SQL Server. They wanted to modernize some SQL instances using managed instance, and they had some new cloud applications they wanted to build, so they choose Azure Database. So let's dive a little deeper into this difference between infrastructure as a service and platform as a service for Azure SQL. Now, it all starts, in my opinion, with business continuity, high availability, backups, long-term backup retention. Everything has to do with HADR. In the infrastructure as a service world, you do have those capabilities, but a lot of times that causes you to configure those things, whether it be your backup strategy, setting up failover cluster instances, setting up always-on availability groups, doing your backup strategy. We do integrate with technologies like Azure Backup to make it easier. We even provide some automation for you if you'll register your SQL Server. But for the most part, it's your responsibility to manage SQL Server to give these capabilities. But you think of platform as a service, let's say that you want to go just deploy a managed instance. Already behind the scenes, we have built-in high availability for you. We have an automated backup strategy, already built in schedule and running for you automatically that Microsoft manages and monitors. And then you can store your backups for up to 10 years in these environments. Furthermore, if you'd like to extend your redundancy of what you're doing in platform as a service, you can declare, I want to geo-replicate my instances or databases, even with something called auto failover groups, where you can kind of extend what you're doing in the cloud. It's a very declarative model. And then you think of scale. Being able to scale things and avoid migrations can be costly. With a platform as a service, you can declaratively just say, I'd like more vCores for my model, and you actually see a lot less downtime than if you were to do that yourself. Or with serverless, we can do auto scaling. We provide advanced security offerings like Azure Defender that reaches across both infrastructure as a service and platform as a service. But there's going to be more security features you're going to get in platform as a service. And then you think about versionless. What does that actually mean? Well, it's SQL Server and Azure Virtual Machine. You declaratively say, I want a version of SQL Server, and you maintain the cumulative updates that go with that, including the operating system. Now, we do have some automated security updates for you if you register your SQL Server. But as platform as a service, there is no longer a major version of SQL Server. You don't worry about patching things anymore. SQL, Microsoft, we manage all the updates that are necessary for SQL and all the components that run the platform as a service. We even have new capabilities called maintenance windows for you to decide when some of those maintenance operations occur. So wouldn't it be nice to no longer have to worry about patching SQL and operating systems? That is really the promise of versionless, along with getting the latest capabilities of SQL, because we can do that in a very easy way inside platform as a service for your deployment. Now, there's a lot of built-in monitoring and intelligent capabilities. We have the new SQL Insights that allow you to run like perfmon capabilities across all of your Azure SQL assets. And then finally, you think about things like indexing. Azure SQL Database, using the power of Query Store and a combination of machine learning and DMVs, can even make recommendations or apply indexes for you automatically. So while SQL Server running in virtual machines is a great option for you to lift and shift, again, a lot of the burden is on you to provide a lot of the management or configuration capabilities, whereas platform as a service, we've abstracted a lot of that for you. We've made it a lot easier and provided you a lot of automation to reduce cost, actually to make your life a lot easier. Now, as you're choosing Azure SQL Platform as a Service, whether it be managed instance or database, I thought it'd be important for you to understand a concept called service tiers. Think of this as like an edition of Azure SQL you're choosing. It's going to dictate resource requirements, limits, price, availability, and other aspects to meet the needs of your application. It all starts with a service tier called General Purpose, which is available in both Managed Instance and Azure Database. This is going to be, per its name, for most business workloads. We're going to use Azure Storage, remote storage, to store your databases, which by default is going to give you basic high availability. Think of like a failover cluster instance for this choice. Now, because you're picking general purpose and because we're storing things in Azure Storage, performance is good, but it's not as high as some of the other options. So you're getting basic performance, basic things like IOPS, and it does, though, unlock the ability to do things like serverless in Azure SQL Database. Now, if those don't meet your resource or performance needs or your availability requirements, you would pick a service tier called Business Critical. And by its name, It's going to give you faster performance because we're going to use local storage to store your databases. It's going to give you higher availability because we're actually going to include things like always-on availability groups built in to meet the needs for your availability. And it's going to unlock new features like in-memory OLTP. Per the diagram I'm showing you here, when you choose business critical, you get multiple replicas like an availability group, including a free read replica. The final service tier choice is specific to Azure SQL Database. Now, this is kind of performance-wise in between a general purpose and business critical choice, but it's going to give you high scaling capabilities, including the ability to store up like 100 terabytes for a given database. So customers that need large database sizes and read scale in a dynamic way are going to want to use something called hyperscale, where we use a tiered architecture to store your data in combination between local and remote storage, which lights up point-in-time restore capabilities that are very, very fast. We'll still have the ability to have replicas using log-changing type technologies. In fact, we have a new feature we just announced for hyperscale called name replicas, imagining up to 30 replicas you could do for high-scaled read capabilities. So unlimited storaging, high scale. So general purpose meets a lot of needs for a lot of customers. Business critical, more expensive, but it's going to really give you more capabilities in terms of performance and availability, and hyperscale for Azure SQL Database for very large scale read workloads. And if you think about customers out there, customers like AccuWeather, HR Block, or ClearSale, each of them have looked at service tiers to meet the needs of their business. So AccuWeather, general purpose, met their needs just fine for what they're doing. They still got basic high availability built in, but H&R Block, through managed instance, needed a very business critical service tier choice to meet the performance and availability needs of their application. And then ClearSale needed huge read scale with large database sizes, so hyperscale fit their needs. So all the additions are your choices for service tiers when it comes to managed instance and Azure SQL Database. Now, if you're thinking about the cloud, besides the fact that we have built-in availability, built-in backups for you, are there other reasons why the cloud and Azure SQL Paas makes sense to me? Well, first of all, Azure Defender is an Azure service which really actually works with even SQL Server in virtual machine or even on-premises SQL servers. Works also really well with Azure SQL Platform as a Service. This is going to give you advanced security capabilities to scan your environment, look for known vulnerabilities, or even proactively look for things like SQL injection attacks, integrated in with the Azure ecosystem, because Azure Defender is across a lot of different Azure services. We just recently announced the new capabilities for SQL Ledger, thinking about in an Azure SQL database, getting blockchain-like style capabilities built into the SQL Server engine. That's now available in preview for Azure SQL Database. And then also right now in preview is Azure SQL Insights through Azure Monitor. Imagine you want a way to monitor all your Azure SQL assets outside of SQL in a capability that almost looks like a performance monitor or a Grafana dashboard. Azure SQL Insights has all those capabilities, and you can do this across all different types of assets you have for Azure SQL. And then you think about intelligent performance. You think about things that we're putting in the SQL Server engine, like intelligent query processing. We have other capabilities that are only available in Azure SQL. So for example, in Azure SQL Database, we have intelligent performance through automated indexing. We can detect query workload patterns that need new indexes or even indexes that should be dropped. We can recommend those or even automate that process to do that for you automatically. So we continue to innovate things in the cloud itself and give you capabilities that only exist in the cloud with your Azure SQL assets. Well, I've shown you a lot about Azure SQL and its capabilities and why it can extend what you can do with SQL Server. I thought it's important to stop right now and maybe perhaps see a demonstration of why we think Azure is the best cloud for SQL. And what better way to do that than to show it from an end-to-end application example. So I've asked my colleague Anna Hoffman to join us to show you such an example of building cloud-born applications. Anna, I'd love to see your example. Can you show us?
Thanks, Bob. So, Bob, I don't know if you know this, but I like to go for a run every morning. I built this really simple app to help people track their runs, and I think most people are familiar with these types of applications. Now, this app was built on Azure SQL, and it just tracks a few things related to my runs. I can also create a new workout, and it will start to log that. it stores this data locally while I'm running, which helps in conserving my battery. But when I complete my run, my app is going to send this data to Azure to be stored and processed. If I switch over to the Azure portal, what you're seeing here is the Azure SQL Hyperscale database, which logs all the activities for users of my app. And you can see it's currently about 13 terabytes in size and can grow as big as it needs to. Hyperscale is going to allow me to get all the features and functionality of Azure SQL Database, plus limitless storage, plus some added benefits around read scale and size of data operations. Now, one common thing we notice is that many people, myself included, forget to click the End Workout button. So one piece of this post-processing includes using a machine learning model to determine where a workout actually ended. We then update the workout data in Hyperscale. As a simple example, I'm just going to manually update a workout from yesterday. When the data in Hyperscale changes, I want to update the records on the app too. I don't want to have to re-pull all the data for the workouts I already have, or even for the single workout I just edited. I want to do as little data movement as possible to just update what I don't have locally. Change tracking allows me to do exactly this without having to develop a bunch of extra code to make it work. So here I created a stored procedure which I can access from an API to return the change table starting at a specific version. And the beauty here is that it can do all this and return JSON in the way that I specify, which is going to make it so much easier for me to process in my app. Now, as a simple example, I can call the API specifying just the version number and user ID and return only changes since that specified version. This is going to help my app perform more efficiently, and as we all know, in a time where phone battery is everything, this is really great. Back in my app, if I refresh, I can see that my workout was updated. So with the Azure SQL Database, and in this case the Hyperscale tier, you can leverage the capabilities built into the SQL engine to help you build more intelligent and faster applications. Now, you saw this app, and that's what's running in production today. But as you might guess, I'm starting to work on a few other capabilities, one which will include temperature information from my run, which I'm hoping I can use for some additional analysis. Let me first push my updates, so GitHub Actions will kick off this build, and then I can show you what I added. I want to add temperature information for my run, so I simply added some additional scripts. The first one adds the temperature column to my table, and the second one that updates my JSON results to include returning temperature. Now, if I switch over to GitHub, you'll see the set of actions I used to deploy my dev environment this morning. Scripts 1, 2, and 3 were deployed to my serverless database, and if I go back to actions, I can see the new changes I pushed moments ago kicked off a build to run a series of tests to update the database and the application. I could have alternatively used something like Azure DevOps. Now, for dev purposes, I don't need all of that data in Hyperscale, but I do need a database with the same functionality so I can run testing and have a good idea of how this app is going to run in production. For this, I'm using Azure SQL Database Serverless. Since I'm only working on this every now and then, I set my serverless database to automatically pause after 1 hour of inactivity. During the pause time, I only have to pay for storage, which is also going to help me keep my dev costs low. But while I'm using the database, you can see that serverless is going to scale on a per second basis automatically to give me exactly the max of CPU or memory that I need when I need it. And I'm only going to be billed for what I actually use. All right, so finally, if I switch back to GitHub Actions, we can see our temperature column was added, so I can go ahead and get to developing. So with serverless databases and GitHub Actions, I can create more cost-efficient and performant dev environments. Satya says Azure is the world's computer, and we believe that SQL is the world's database. Thanks, and back to you, Bob.
Wow, and thank you for that demonstration. You know, one of the things I loved about what you showed us is that Hyperscale can provide that very large, I think you said like 13 terabyte database for your application, and including core engine technologies like change tracking. But then you switch gears as a developer and use serverless with a smaller scale database, and then combine it with GitHub for a true DevOps scenario. So this is truly the power of being in the cloud. Using Hyperscale for that limitless storage, but using serverless to save your cost while you're building your application, and combining all of that with very DevOps type pipeline scenarios. So thank you for that demonstration. Well, now you've seen the power of the cloud and what Azure SQL can provide, including this great demonstration by Anna for an end-to-end application scenario. You may be thinking today about migrating your SQL Server to the cloud. And you're probably wondering, like, where do I start? So first of all, notice the URL we have on the screen right here, a one-stop hub called data migration for all the different combinations of SQL servers and even actually third-party databases, and how you might migrate those databases and instances to the cloud. We just announced, though, a new tool called Azure Migrate with an appliance, specifically, at least right now for VMware servers, where you can go and assess and discover thousands of SQL instances in your data center. Get recommendations on what is the appropriate target for Azure SQL, whether that be SQL Server in Azure Virtual Machine, whether that be Azure SQL Managed Instance, or Azure SQL Database even. And so you get those recommendations for running this assessment, but we go further than that. We can monitor your workloads in those environments and give you specific service tier recommendations or even cost estimates of what it's going to be like to go run that workload now in the cloud. That's Azure Migrate. You may be thinking, though, in terms, I've got a SQL Server instance, I'd like to migrate that in a very simple fashion to maybe something like Azure SQL Managed Instance. And I'd like to do that in maybe a tool like Azure Data Studio. So we now have the capability in line with Azure Data Studio right now in preview to do an online or offline migration through a series of wizards in the tool to take a SQL instance and simply move it up into the cloud with Azure SQL Managed Instance. Now, some customers have told me that in order to make this migration to the cloud, they need to do this online. They cannot afford a lot of downtime to make this migration decision. So we have today Azure Database Migration Service or Log Replay Service to take an existing SQL Server on premises and use log shipping technologies through backups of databases and logs to do an almost zero downtime restore and migration into things like Azure SQL Managed Instance. We think we have the tools and the resources you need to make those migration decisions, so don't be afraid to go take a look at our Data Migration Hub to decide that. If you remember back to my original SQL Edge to Cloud asset slide, at the bottom was Azure SQL Edge, SQL Server 2019, and SQL Server on Containers. And then the public cloud at the top was Azure SQL, SQL Server in Azure Virtual Machine, Azure SQL Managed Instance, or Azure SQL Database. And we showed you examples where these technologies can be different, but still stitched together with a common T-SQL language and tool set and core engine capabilities. So now, the last piece of this puzzle, the SQL Edge to Cloud, is hybrid. So let's talk a little bit about Azure Arc. Now, we believe in hybrid computing. We believe that there are scenarios where you need to run your SQL Server assets in your infrastructure, but you want to connect or take advantage of the power what Azure can bring. We showed you all those right examples with Azure SQL. This is exactly what Azure Arc-enabled data services are all about. In fact, a company like Ford has told us we're comfortable running our data center, but we love some of the innovation you are doing in Azure, like Managed Instance. So is there a way for us to connect with Azure and get some of the platform as a service capabilities in our infrastructure? That's exactly the announcement we made with Azure Arc-enabled SQL Managed Instance. So first of all, this is a core SQL Server engine, just like SQL Managed Instances, but it's also a versionless SQL Server. Yes, in your environment, it's an evergreen version of SQL Server, so you can take advantage of all the latest updates without the hassle of patching SQL Server. It's elastic in scale. Deploying this as a pre-deployed SQL Server and deploying it is just like SQL Managed Instance. You can actually scale cores and resources in a very dynamic fashion. The connection to Azure can give you a very unified management portfolio now. Imagine your Azure SQL assets are viewed through the Azure portal, but also your Azure Arc-enabled managed instances, even though it's running in your environment. Imagine integrating and looking at things like billing, usage, inventory, metrics, and logs, all from SQL running in your environment, but still see that with other Azure SQL assets through things like the Azure portal. You're still going to get the great security capabilities you know with SQL Server today, whether that be SQL Server authentication, roles, Azure Active Authentication as well, but also, how about bring the power of Azure down? How about taking a look at Azure rollback access control and policies from Azure, and now using that to govern your assets in your environment through Azure Arc SQL Managed Instance. And And one of the most important aspects of this is billing. Now, for the first time, you're going to be running a SQL server in your environment, but you're going to be billed as you had an Azure subscription. You're going to have an Azure billing model where you upload information about your usage, and we will bill you just like Azure SQL services. So how are we going to achieve this? Well, we're going to achieve this by the following. You are going to provide the infrastructure. You'll provide the hardware services. You could even run it in a multi-cloud environment, but you're also going to provide Kubernetes. Kubernetes is going to be a platform, an orchestration platform for containers, which is the technology powering Azure Arc SQL Managed Instance. These containers are going to be running Kubernetes in a way that's going to give you all of these capabilities. We're going to provide services behind the scenes, things like data controllers or automatic backups or auto HADR like platform as a service, but we're all going to use the power of the Kubernetes platform and the Kubernetes of your choice to all make that work. So Azure Arc enabled SQL Managed Instance is the stitch in between SQL running on premises and SQL running in the public cloud, the power of Azure running on your infrastructure. Wow, I realize that's been a lot to take in, whether it's Azure SQL Edge or Azure Arc, SQL running everywhere you can imagine. And you're probably wondering, when should I use some of these? What should I use in what scenarios? Now this table is pretty complicated, so you can look at this later to kind of look at every little checkbox, but notice the idea that we've got scenarios down the left-hand side and which SQL Edge to Cloud assets at the top that might apply for those scenarios. So if you need IoT applications, Azure SQL Edge, even Azure SQL Database can be that choice. If you need instance level capabilities, you've got a lot of choices, including SQL Server Containers, Azure SQL Edge, or even SQL Managed Instance, or now Azure Arc SQL Managed Instance. We want to make sure you have the information you need, so consult with a table like this to decide, based on a scenario I have, what are the right SQL Edge to Cloud asset for me? And many customers have told us it's not just one scenario or one asset I need. Many customers are finding themselves today needing to deploy SQL Server on the edge, in the cloud, or in hybrid capability. And you're asking yourself, well, but how am I going to do that in a consistent way? How am I going to keep my skills relevant? Remember back, it's the same T-SQL language. It's the same core engine with security, performance, and availability, and the same tool set that can connect and power across all of these assets. Well, you've seen the latest innovations for Azure SQL, SQL Edge to Cloud, SQL Server. What about the future? What's going to happen with Azure SQL? What's going to happen with SQL Server? Well, you should know that all of those assets are strong and alive and well. And in fact, one of the things we're trying to do, as you saw today, is unify SQL across the cloud, across on-premises, with specific capabilities. Arc is an example of doing that. We want to connect more your SQL Server in the infrastructure of your choice or the terms of your choice with the power of what's going on in the cloud. We want to invest more for developers. We want to invest in modern frameworks. We want to make sure that our T-SQL language is up to par with the needs of the modern application developer. We want to make sure we're embracing types like JSON and Graph and continue to invest in IoT scenarios. We believe in Azure SQL technologies like hyperscale and serverless give you the best chance to succeed. You saw the demonstration for Anna where she used a combination of these technologies to power production, but also save money when it comes to development. We want to continue to enhance those technologies in Azure SQL. Security is so important to every business today, so confidential computing is really important to us. We think in continuing to invest in things like enclaves, towards technologies like always encrypted, or to make sure that we're integrating more with technologies like Purview for governance or classification reasons, and even bringing you things like ledger technologies to support tamper-proof data in your SQL environment. We believe SQL is the modern data platform wherever you want to run it. We want to continue to invest in built-in intelligence into the engine itself. We want to enhance technologies like data virtualization that you've seen us do already, and make sure that we integrate well with all the needs you have for analytics. We do believe the future is ours together to create, and we think that Azure SQL and SQL Server are going to provide that future for you. Now, you've seen a lot of information, but I know you want to learn more. And on this particular screen right here, you see a lot of different assets we have for you to learn a lot of different things across SQL Edge to Cloud. Everything you see right here is powered and built by the engineering team. Whether it be Azure SQL Fundamentals to learn more about Azure SQL compared to SQL Server, to learn more about migration, or to follow the latest news about SQL and Azure SQL. You may want a lot of digital content, so follow us on our YouTube channel. And remember, at the top right here, you're seeing information about today's presentation that you can download today, the demonstrations we've shown you, and more, including this great application demo that Anna did. And then we're a believer in making sure we power and improve your knowledge through even books. We've written several books over the last few years about the technology that we're talking about today, all written by the Microsoft engineering team. We're a big believer in giving you the information you need so you can empower yourself and learn more. I also want to make you aware of an upcoming important digital event led by Rohan Kumar and Mike Flasco to talk about Azure Purview, a unified automated governance solution across all of your assets. You're going to see us continue to invest in Azure Purview and its integration into Azure SQL because we believe it's a great way to unify your governance and policy needs across wherever your SQL assets need to be. So join us and register today for this event coming at the end of September. At Microsoft, we do build the products and services, but you, the community, power them. We have built a new Azure data community that you can use to find and join a user group or to explore and find new upcoming events. All sorts of great resources, all created by you and experts in the community for you to learn from. So take a look at the new Azure Data Community. I think you're going to find the worldwide presence of Azure Data is powerful and more bigger than ever. Thank you for attending today's session. On behalf of Microsoft and all my colleagues, thank you for being a part of the 2021 Data Platform Summit. Thank you to all the sponsors and exhibitors that are part of this great and wonderful event. I know you have a lot of great sessions and experts to meet over the next week. Hey, you might even see me in some of those sessions as well. So thank you again for being part of this great event. Hope to see you at the next event soon.